Hey guys, welcome back to the shop. My name's Adam. So I got my next project here in front of me that I'm getting ready to start on, and this is going to be my next video. I wanted to go ahead and share this job with you on video and show you how I tackle it. So what I've got here is a motorcycle piston, and this belongs to some good friends of mine down at D&D Cycles, and they need some modifications done to this piston. And this is actually not something that I typically do in my shop or have ever done when we were at the old shop. Usually the automotive type stuff, we would always just recommend them go to see automotive machine shop. There's a few here in town because they usually have setups that they can do things in a little bit quicker fashion, I guess, than what we could do. But so I talked to him. He brought it to me. He said he had something for me to do, and I talked to him, and I told him, I said, this is going to take a little time to do. I want you to be sure that you want me to do it, because I don't want this I don't want this to be something that you could take to an automotive shop and they charge you $50 for. But he said, no, go ahead and do it. He wanted me to do it, so I'm going to tackle it. So what we got is a piston, and it's a big bore kit. I don't even know what bike it is. I didn't ask them. But what they want done is where you've got your valve reliefs on both sides for your exhaust and intake valves, they want this cut down 60 thousandths deeper. And what he did is he went ahead and installed it into the cylinder, and he used a transfer punch to punch a center where the valves go, down through the cylinder head. So I've actually got 4 punch marks there that will be the center of the valve that I can work off of, and that's a huge help right there. So what I've decided that I'm going to do, how I'm going to do this job, is first of all, you got to figure out how you're going to hold it, down and get it set on the angle. Well, I've got that adjustable table over there that I've showed in the video. It's like an angle plate, but you can adjust it. So what I'm planning on doing is using that, and I'm going to get it clamped down on that table and get it adjusted up real close. And I went ahead and used one of my little angle tools here, and I just kind of got a close estimate of what this angle is going to be, and it's actually about somewhere close to 25 degrees. So what I'll do is I'll get this set on my angle plate and get it clamped down. And what I'll probably do is I believe this was 22 millimeters where the ring, the pin goes through here. That was 22. I might have a piece of drill rod. I don't know yet because I haven't looked, but I'd like to find a rod that'll fit through there nice and close and have it to where I can clamp it down with the rod sticking through there and have a couple of clamps to hold it down. So that's my idea to hold it. My first idea was to maybe put a little clamp on top and bottom there to hold it, because it is machined here on the skirt. But I'm probably going to see about running a rod through here and clamping it on each side. And so once you get it clamped, I've got to do some indicating. I want to make sure that this area here is flat, and then I want to get it indicated front to back. You got a little short area there that you can run like a test indicator on, and get that table adjusted to where this is completely flat there. And then once you get all this set and you get it where you want it, I'll run in there and find the punch mark with probably my coax indicator and find the center where each of the valves, the undercuts here, I'll find center using a coax most likely. And then you got to deal with cutting it, and I don't have any end mills the proper size that I need to cut these, the diameter of the valves here. You got one that's I believe it was 38. Yeah, the exhaust valve is just a shade under 38 millimeter, and your intake valve is going to be 30 millimeter. And the other thing that you got to deal with is, you can see here, it's radiused inside. On both sides it's radiused. So I want to kind of match that radius in there. I don't want to use a sharp cutter like an end mill and go in there and have a sharp corner. I would actually rather my cut match this radius that's up inside here. So what I'm going to do is I'm going to use a couple of my small fly cutters, and I've got them right here. I picked out a couple. I got a couple small fly cutters. Here's another one here. And what I'll do is actually use my fly cutters. I'm going to grind me a tool bit using some high-speed steel tool bits, and I'll measure about what the radius is here, and I'm going to grind my tool bits to match this radius. And I want to, the other thing I got to deal with is getting it set on the diameter on what I want this to cut whenever it's turning. So an idea that I have for that is, it's actually pretty quick and simple, is just take a piece of material, say a piece of steel tubing, chuck it up in the lathe, bore it to the size that it needs to be, you know, 30 and 38 millimeter. And what I'll do is once I get my tool ground, I'll chuck this in the tailstock in my big chuck and set my tool in here, and I'll go in and I'll touch it off on that bore, and that way I know that this tool is set to the diameter that I want it to cut. And I'll do that for both of them there. So that's the plan that I have in mind. You know, I've been sitting out here this afternoon looking at it, trying to get a game plan on you know, figuring out the best way to do this. It's not something that you just want to try to throw up in the mill and just throw an end mill in there and cut it. You know, I want it to be right, so I want to do the job the right way. And I'm not an automotive machinist. I've never done automotive machining, so I'm not sure the tricks that these guys use to do this kind of stuff. The guys here in town may have the same thing. They might have a Bridgeport sitting in their shop. They do the same kind of job, so I don't know. This is the way that I'm going to do it, and I'm going to show you along the way. I thought it'd be pretty interesting to watch, so I'm going to get started on it here. So this is what we got to do. Got to cut them 60 thousandths deeper. So I'm going to start gathering some materials. So I'm going to find me a couple tool bits and get this thing going. Okay. All right. So I've been getting my stuff set up, and I wanted to go ahead and show you how I'm going to hold this in the mill. This is my what I've always called my adjustable angle plate. They're also known as like tilting tables. I'm not really sure the correct term for it, but I just call it my adjustable angle plate. And this is actually a really good old unit right here. This one's made by Taft Pierce. It's very heavy duty. It's got a nice scale on there with your you know, your graduated degrees, and it's got some T-slots. There's a couple tap holes that I put in it whenever I had something that I needed to hold, and I wanted to use some 5/8 studs. So I'm going to give it a little cleanup because I haven't used it in a long time. But anyway, found some T-bolts, half 13 T-bolts that fit the slots nice, perfect. That's like the perfect size for them. I had to file it just a little bit to get them to fit because they were a little tight. So see, that one's still a little snug. But what I'm going to do, this is a piece of this is 20 millimeter drill rod right here, and what I need is 22. I've got a piece of 7/8 drill rod over in the lathe, and I'm going to actually machine one to fit the wrist pin hole here. I want it to fit nice and close. This one's moves around a little bit too much, but I'm just going to show you what I'm going to do here. So I'm going to make another rod that'll fit in here close, and it'll be clamped up here on the angle plate like this. The rods will stick out, and I'll have my little strap clamp on each side with a little step block here sitting up there, and I'll get it up here adjusted on the right angle, and then start indicating it and get this indicated flat. So I wanted to give you a quick little shot of that and show that, because I haven't showed this yet in any of my videos, and this is what I'm going to be using. And by the way, Tom, if you notice me sweating, which I am because it's hot, it's here it is, early December, and it's hotter than hell. It's muggy, and that cold front that everybody's getting right now with all that snow, well, we ain't getting it, and it's hot. So I've been running my fans, but I have to turn them off so everybody can hear me on camera. So all right, I'm gonna keep rolling on it. Just wanted to give you a little shot of this. All right, I've been cleaning up this angle plate here, and I just wanted to show you. I'm a little proud of my work right here. This thing had been sitting around for quite a while, unused, and it was getting a little neglected, so it had quite a bit of surface rust established on it. And whenever I had turned it and showed you, this was the side here that had quite a bit, because this is the side that was always up, sitting over on the shelf. So I just used my red and my gray Scotch-Brite and just rubbed it real good, and got her cleaned up. And this is actually a really nice piece. I wanted to give you a little bit better shot of it before we get started on the work. But you see there's the back there. But this thing is really nicely built. And this you know, the gauge here for your angle is really nice. That polished up nice and shiny right there. And it's graduated in degrees and minutes. You got another scale up here that reads in minutes, and I never noticed that before, because I mean, it's been a long time, so if I did, I done forgot about it. But it's like right now it's reading 33 degrees and 15 minutes. So that's really nice. I'll see if I can get you a little better close up there of it. As I said, this one was built by Taft Pierce, and it's actually right there. Hopefully you can see that, the Taft Pierce logo that's engraved in it. And you can loosen it here and loosen it there, and it's got a really nice snug fit, and you can bump it around, move it, and get it set where you want to. So alright, I just wanted to show it off. Something that I've been wanting to get to and get cleaned up, and I didn't do a full detail, but I did get all the rust off of it for the most part. And when I'm done with it, I'm going to give it a good wipe down and coat it down with some oil. So there's the angle plate. All right, I'm gonna go ahead and get started on some work now. Ain't got much to come off this drill rod. I'm gonna try to finish it at about around 865 or so, but I'll fit it. That's exactly what I was looking for right there. Had just enough for it to slide on. I finished it at 865. Yeah. Alright, that'll work there. I just got to go cut it off. Alright, so here's where we're at. I'm getting her set up and getting ready to start doing some indicating here. So I've already got the angle plate clamped down, and I went ahead and indicated it. I wanted to go ahead and indicate it straight, so I've got that indicated, you know, parallel with the table. And here's the new rod that I made to fit the piston. I've got her clamped just lightly. I don't have it clamped tight. So the next step here is to go ahead and get this indicated flat here, and after that I'll indicate it front to back to get the angle set as flat as I can. And another thing I wanted to point out is my stupid fluorescent light right above the mill here decided that it doesn't want to come on now, so I guess the ballast has gone out in it. So I'm low lighting, and I went ahead and repurposed my one of my fan mounts and got my clip light on there. And I wanted to go ahead and put it behind me anyway, because I've noticed in my videos that the light's usually right here. I get a lot of glare in the camera, so I wanted to go ahead and put it behind me, so you're not getting blinded by that light. And I've also got my double boost light hooked up for the first time. That's the little clip light, and I think I think it'll work out. I've got it clipped right here on the you know, this housing here, and it's clearing the belt fine. And we'll give you a little example of what kind of difference it does make. See, they do work pretty good. They don't put out quite as much light as those clip lights, but they do work good, and they help. So in my case, I'm probably gonna have to go buy me new ballast and fix this stupid light above the mill here, because it sucks not being able to see. It's dark enough in here as it is. Alright, so anyway, got this set up, getting ready to do some indicating. I've still got to make my tool bits for the fly cutters, so I got to go do that, and we'll start indicating. Alright, I found me a little tool bit. I'm going to go ahead and get the first one ground. Got the fly cutter and a radius gauge. The 3/16 tool bit pretty close. Got it kind of matching that radius on the radius gauge, so I just got to do a little honing on it. So that's that one. Now I got to do one more. Alright, got the next fly cutter, and found me another little 1/4 inch high-speed tool bit. This one was cut off, so I'm gonna regrind it. one ground. Got it to fit the radius. I got to do some honing to finish it off. Alright, getting close. Doing the small one first. For about 30 millimeter. Well, that's right there at it. Alright, I think that'll work. Alright, I got my fly cutter set up in the chuck. This is proving. This is going to be a little bit tricky. I've got to find something to kind of hold it in there. All right, I gotta give it a little bit more relief on the bottom. The bottom edge is touching. All right, we'll try it one more time here. All right, there we go. I got it touching it that time. Okay, first one set. For about 496. There's 38. All right, I think I'm good with that. Just barely touching.